Hello and welcome back to another episode of Math with Sohn. Today, we're going to be doing some dice problems. All right? So these are some interesting ones. Johnny is raising money for some new shoes. How fun. He plays a game that involves people throwing two dice. It costs $1 to play the game, but you receive $2.50 if you win, if the player wins. A win occurs if the numbers thrown differ by more than two. Johnny has had 801 games. Johnny has been a pretty successful fella. Then, how much money would he have earned to buy his new pair of shoes? So, this is a typical dice problem where it would be very helpful, very, very helpful to realize that when you're throwing two dice, the only way that it could happen is if you roll what I'm about to write out, all of them. I'm going to try and write it out as quickly as possible. A 1 and a 1, a 1 and a 2, a 2 and a 1, and 1 and a 3 and a 1 and a 4, so on and so forth. And then you could have 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, and a 3 and a 6. If you list out all these, you're going to find out pretty quickly that you're only going to have, in total, 36 different possibilities. And that is important because those possibilities are the likelihood, potentially, at least the total, opportunities for a player to win, in a way. All right, well, let me get it finished real quick. 6, 5, 6, 6. Tried going quick. Sorry if it's messy. So how many of these differ by more than two? Well, let's look. The only way they're going to differ by more than two is probably when it's a really high number and a low number. So the 1 and the 6 will do that. And the 1 and the 5 would do that, and the 1 and the 4. So 1 and 6, 1 and 5, and 1 and 4. That would do it. What about 2 and 4? Nope, that's not more than 2. 2 and 5 and 2 and 6. So you end up with these three, and then these two. So 2 and 5 and 2 and 6. And then the 3 and the 6 is the only one that would work in that last column. And you might even see a pattern here. Because when we start on this corner, we get these three. And then we would have these two that differ by more than 2. And then we'd have this 1. These are the numbers that differ by more than 2. So out of all of those numbers, you can count them up. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total numbers. I didn't bother listing them all out, but there's 12 here that would be good for you, the player, to win. So 12 out of 36 chance of you winning. That's important. So if you simplify that down, it does turn into 1/3 of a chance of you winning, the player winning. But that means that Johnny, the guy taking all our money, he wins 2/3 of the time. Okay, that's important. So let's take this away. We got Johnny winning 2/3 of the time, us winning 1/3 of the time. Well, if he's played 801 games, that's very important. That means that he has taken in $801. Okay. Well, that's how much he took in. How much did he pay out? How much did he have to give all the other players that were playing this game? Well, 1/3 of those 801 games, the players won. So 1/3 of the 801 games, if you take 801 and divide by 3, that would mean that the players won 267 games. Quite a few. And for every player that wins, how much does he have to pay them? $2.50. Now, technically, they only netted $1.50 because they still had to pay $1 to win, to play. So if you multiply that by $2.50, he will have expected to have earned $667.50. All right, not earned, excuse me. That would be how much he would expect to pay, excuse me. So he had to pay the players back $667, but how much did he earn? Well, he earned, he took in $801, and he had to pay out that $667. If you subtract them, 801 minus 667.5, you would get $133.50. So Johnny has only earned $133.50 on, probability statistical average. All right? The next one, also a little bit of a weird one. You got two pairs of dice. One of the dice is red and the other one is blue. We are Johnny this time, are deciding to open up a small gambling game. When a player rolls both dice at the same time, the red dice is multiplied by 10, and the blue dice is added to that red number. So it's not that difficult. We're just getting pretty much a multiple of 10 here. So assuming that the player is not colorblind and can tell the two dice apart, if the red dice showed a 2 and the blue dice showed a 6, the player would have a 26 because he would do 2 times 10 plus 6 makes 26. If the player wins, they win twice the amount that they bet. If they lose the amount of the bet. So if a player bets $5, they will either win 10 or lose the $5 bet. What are the chances that you, the house, not the player, have a chance of winning if the money, if the player's money, if in order to win, the player wins, they need to get a 47 or higher. So again, we go back to this. You're throwing 2 dice. All right? So if you're throwing 2 dice and you have to have a 47 or higher, that would be the cutoff would be, well, here, right? Because 46 is not going to win. Win be not. Everything on this side, the player would lose. Everything on this side, the player would win, because here we would have 51 and 52. Quite literally, 51 and 52 and 53 and 54 and 55 and 56. So these would be the only wins, which again is 12 out of 36 chance, which is a 1 out of 3 chance of you winning, the player winning, which means the house, which is us this time, Johnny in the previous one, will gain 2/3 of the stuff, okay? So the player has a 1/3 of a chance of winning, but we are asked what are the chances that you, the house, would have a 2/3 of a chance of winning for the house. House wins. What is the minimum score that you, the dealer, could allow for a winning score and still be able to ensure that you would have the odds still in your favor? Well, you need to have 51% of the stuff there, right? Because technically, you need to win more than half, right? Let's think about that for a second. If you win, you gain $5. If you lose, the dealer, if you lose, you would only lose $5. Yeah, you paid 10, but you actually gained 5 from that original bet. So you really only lost 5. That's an important concept to recognize, that when you pay 10, they still gave you 5. All right? All right. So with that in mind, you just need it to be above 50%. If it's above 50% out of these numbers, you need to make sure that the cutoff is not here. Here is where 50% is. I'm going to box it. You would need to make sure that you also get this little chunk of 41 in there. So they would have to score less than 40. You would have to make sure that they would have to score more than 42, because that would be slightly less than half. So the answer to that one would be more than 42 would ensure that you would have enough of the odds still in your favor to be able to secure a victory. All right? That's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Enjoy those dice questions. Bye.